Hello viewers, thank you for visiting again. Today we'll be continuing our next hands-on number 10, which is part of our designing and implementing a data science solution on Azure. Today we'll be starting this hands-on, create a batch interface inference service. So I've opened this link in a new tab. Now, here in this topic or in this hands-on, create a batch inferencing service. What we have to do. In many scenarios, inferencing is performed as a batch process that uses a predictive model to score a large number of cases. To implement this kind of inferencing solution in Azure Machine Learning, you can create a batch inferencing pipeline. So here we'll have a predictive model already created, or maybe we'll be doing that during our hands-on. A new predictive model will be creating, then we'll be registering that model as an asset, and then we'll be using that predictive model for batch inferencing. Rather than on a single data, we'll have a large number of data set that we will be uh, passing on to our predictive model, and then we'll be getting the prediction for each of those cases. Okay, so the prerequisite to start the hands-on is to create a Azure Machine Learning workspace and then clone the Jupyter notebook within your Azure Machine Learning studio. Okay, that has been covered already within my first YouTube video for this playlist, or for this Azure Machine Learning course. You can visit in my YouTube channel and then complete that one. I'll be continuing with this section where I'll be opening the notebook related to batch inferencing service, and then we'll start our hands-on. So here if you see, I have completed that part. I have cloned all the notebooks and I have kept open the relevant notebook, which is to create a batch inferencing service. I will minimize this sidebar and I will start the compute resource. While compute resource is starting, I will explain what we are going to do within this hands-on. So we'll be creating a batch inference, okay, pipeline, and then we'll be passing on the data. Let's suppose a scenario where imagine a health clinic takes patient measurement all day, okay, for different parameters related to their health, like pregnancy, plasma glucose, diastolic blood pressure, tricep thickness, serum insulin, BMI, diabetes pedigree, age, all these parameters that will be recorded within the clinic, health clinic, okay, for whole day. And then overnight, the diabetes prediction model can be used to process all of that data, day's patient data as a batch. Now generating the prediction that will be waiting the following morning so that the clinic can follow up with the patient who are predicted to get a risk of diabetes. Okay, so the all day patient measurement data that we have took, okay, or the health clinic took, will be used for running a batch prediction or batch inferencing on top of that data, and then we'll be getting the prediction for the patient or whole patient, and then based on the prediction we can consult, or the patient could be consulted, okay, for higher risk of diabetes. Okay, so that kind of batch inferencing pipeline we are going to implement in this exercise. Okay, to do that we have to connect to our workspace. Okay, for that we have to import the Azure Machine Learning core component, or import that package, then also import the workspace package from Azure Machine Learning. Okay, and here you will see that Azure Machine Learning package and the machine learning workspace names are being printed, which we are going to use to run or create batch inference. Okay, now here we are importing our diabetes data, okay, from a CSV file. This is the same file where health clinic is going to put all the data for the patient for a single day, I suppose. Okay, and then that data will be marked as these column names, then that data will be split into test and training data set, right? And these are all the relevant packages, Python packages that we are importing, right? Experiment package from Azure Machine Learning core component, model for creating and registering the model, pandas library for creating data frame, numpy for numerical Python package, right? To run numerical uh, exploration on the data, then model selection, okay, test training split, okay. This is a tree classifier. This will be a classifier algorithm being run to train our model, then ROC AUC score and ROC curve from the scikit-learn package, scikit-learn.metrics package. From there, we are exporting, importing all these packages, and then we are creating an experiment, okay, within our machine learning workspace, okay. So that's what it is. Then importing the data of the diabetic patients, labeling them, splitting into training and test data set, running a physical tree classifier within our using our training data set, and then creating a model and predicting whether model is performing properly or not. The accuracy of the model we are trying to check using the test data set. Test would be a newer data which will be run on our model to check the accuracy, and then we'll be calculating the AUC score. Accuracy already we are printing here. Then we are saving that model, okay, training model, and then within that folder, it's being written into a folder, and then we are registering the trained model, okay, using that model name. Then these are some tags we are putting for that model, and then accuracy and AUC scores are also being set, okay. So this is where we are registering our model as asset, and once that model is registered, we'll be able to see the model here, okay, in the asset section in Azure Machine Learning Studio. So let's run it. This is going to take some time. So go and get a coffee and come back. Now, generate and upload batch data, okay, while this model being trained and registered, okay. Okay, here you can see the accuracy of the model, okay, and then AUC score being printed, and model training is complete and also registered within our model section. If we'll open this in a new tab, we will be able to see the new registered model here, okay, for today, February 1st. This is the new version of the diabetes model that we have trained, okay, and tested for the accuracy, and it is giving almost 89% of accuracy, okay. Now, generate and upload batch data. So here in this section, we'll be generating and then uploading the batch data. Since we do not actually have a fully staffed clinic with patients from whom to get new data for this exercise, you'll generate a random sample from our diabetes CSV file. Okay, so we are going to generate a random sample from the diabetes CSV file that we have, upload that data to a data store in the Azure Machine Learning workspace, and register as a data set. So we'll be uploading a file, CSV file, a random sample of diabetes patient, okay, data set, and then we'll be registering those data within our data stores here, okay, and then as a data set here, okay. Now, so here we are importing dataset and data store packages from Azure ML core component, pandas library, and then operating system. Now here we are connecting to a workspace blob storage, which is our default blob storage that we have already created within our workspace while provisioning Azure Machine Learning VM. Okay. Now, from that data store, we will try to print, okay, the data store, and from that data store, we are going to store this CSV file within our data store, okay, with all these column names. Okay, you get a 100-item sample of feature column, not a diabetic labels, right? So we are just creating a random sample from this data set basically, or the diabetic data. Okay, now we are creating a batch folder. Okay, within this folder we'll be saving our sample file. Okay, this sample file will contain sample data of the diabetic patient, which will be a batch data will be sending to our model for production. Okay, and then we'll be uploading this data store within data store. While the sample file once gets created, we'll be uploading it to our data store, and then from that data store, right, we are registering that file within our data set. Okay, here if you see, it's trying to register a data set for the input data. Okay, it is going to take the same file path where we are writing this CSV file or uploading this CSV file. Okay, so let's run it. This is going to generate and upload the batch data. Okay, workspace blob storage, true. From there we can have blob storage, file storage, or directory storage, and then certificate store. Out of that, we are using the blob store. There we are creating a folder within the data store, and then we are storing our randomly generated sample data in the form of CSV file. Okay, now data store upload is, please use data.file upload direct to upload the files. Factor in create file dataset in single method call. Okay, so this is a deprecated version, but it's still going to work, and it has uploaded the data within the data store, and we will be able to see the data set here. Okay. Here you see we created a batch data, and if we want to explore that data, we can see here. Okay, the number of files, there are these number of files got created, batch of sample data. Okay, display as grid. Here you see we have created 100 files for each of the patients. Okay, now for each of the patient we have created these files. Okay, I'll close this tab. Now we are going to create a compute resource, okay, or compute cluster basically, which will have a node of 2 to 16, sorry, which will be a dual core. Here it will be a dual core cluster with this standard data science 11 version 2 VM size, and then once the cluster is created within our workspace, right, we'll be passing on our data. So for that we'll be creating a pipeline and then playing all the data files onto our inferencing onto our model. Okay, so first let me put a cluster name here. I'll just name it as a compute cluster. Just compute cluster, so that it will be 2 to 16 character long. It will follow this name. Okay, so that's my cluster name. Here we are checking for any existing compute target. Okay, within our workspace. If we have existing cluster, then use it. Otherwise, you provision it. Okay, so here it will provision a new compute cluster if it's not available. Okay, so I do not have any compute cluster created, so I will just create this is going to create a new cluster for me, compute cluster for me with 2 nodes. Okay, so let's run it. It is executing. Let's give it a some time. You can see succeeded provisioning the cluster. Okay, and then we can see the minimum number of nodes requested have been provisioned. So these many number of nodes with 2 nodes, our cluster is created. And if you want to see the cluster, I can go to home. I can open it in a new tab, and here we go to compute. We can see this compute cluster batch. Okay, so this is created now. Okay, and if you see the number of nodes can go from 0 to 2. Okay, this is our VM size that we used for provisioning our cluster. You can see also the cost, CPU, all this information, and the number of nodes. And it would go to idle state if you are not running or using your cluster for more than 20 minutes. Okay, so now our cluster is created. Now will be compute cluster is created. So we have a compute resource, we have our data set. Now we'll create an automated pipeline for batch inference. Okay, for that we are creating a specific folder where we'll be putting all the experiment related artifact, like our Python script, which is going to test and train our model and use it for batch inferencing. So all those artifacts, model, everything will be put here, okay, within this folder structure folder. So let's create this experiment folder, batch pipeline. If we refresh this here, we'll be able to see batch pipeline folder created here. Okay, it has nothing as of now, but let's proceed. Here, if you see, we are trying to write a Python script which is going to call the diabetes model, and by default it will take the latest version of our model that we created, right? Diabetes model. On top of that, it is going to run the data set, okay, batch of data one by one, and then print the result of the prediction. Okay, so this is just generating a script and writing within this folder. Okay, this is not actually executing the script. So this file has been created, and if I'll refresh, so that script file has been generated here. Okay, here you can see. So this is our script to get the model, registered model, and then use that model to do a batch inferencing. Okay, here we are doing batch inferencing one by one, cleaning the data and printing the result. Okay, now moving on. To run any Python script, we need a specific environment to be created, okay, within our compute storage, compute resource. And to create an environment, we take help of a YAML file. Okay, this YAML file will be used to import all these Python packages which are set as a dependency within our environment file, and then it will provision a conda environment to run our Python script, okay, that we generated here. Okay, so this is going to create a YAML file, and this will also be put into the same batch pipeline folder location. And here, once I will expand, you can see the batch environment file as well. This will be used to import all these relevant Python packages to run our Python script. Okay, now we are registering that environment or provisioning this environment within a Docker image. With the help of a Docker image, we are taking default CPU image, we are importing it from run configuration, and that Docker environment, that Docker image will basically take this environment configuration and provision a Python VM, basically a cluster where we are going to run our Python experiment. Okay, now Now let's run this. So now the configuration is ready. Okay, and our environment is configured with this within this Docker image. Okay, next you are going to use a pipeline to run the batch prediction script, generate predictions from the input data, and save the result as a text file in the output folder. To do this, you can use a parallel run step, which enables the batch data to be processed in parallel and the result collected in a single output file named parallel run step.txt. Okay, so this is the file where all the results of the inference, okay, batch inferencing that we are going to do will be stored as an output. Okay, and we are using the parallel run step. This is parallel run step where we are calling a parallel run step method, and that is part of our Azure ML pipeline steps. Okay, this parallel run configuration and parallel run steps are being imported from pipeline steps of Azure Machine Learning package. Okay, and then with Azure ML.data, we are importing output file dataset configuration. So this configuration, basically we are running an inferences configuration. Okay, output directory. So that's where we are going to put the result. Okay, now within this parallel run configuration, what values we are passing? We are passing the experiment folder from where Python file will be referred to run the inference. We are creating a batch of 5. That means it is going to run the inference for 5 patients or 5 records at a time. Okay, parallelly. Error threshold is 10. That means if we face the error more than 10 times, it is going to stop and will not run the inference. We have then append row is nothing but just from out of the 5 batches, right? All the results will be appended within output file, which is parallel run steps.txt. Okay. Then we are passing the environment configuration and then cluster information that we created, right? Here we created our cluster. This one. We provisioned our cluster with this VM information. So that same cluster will be used to run our pipeline inference. Okay. And not count is 2, that it could use maximum 2 clusters, okay, to run our inference script. Now that same parallel run configuration will be now used here, and then batch is for diabetes is what our step name would be or experiment name would be. Okay, pipeline name would be. And then we are passing the data diabetes batches as the input, right, from this batch dataset directory. Okay, and then we will be putting the output within the output directory. Arguments empty, allow reuse true. This will be reused again and again for running the batches. Let's run it. The steps are defined. Okay, so all the steps are defined. Now here, now it's time to put the step into a pipeline and run it. So now here we are defining a pipeline. So we are taking help of our workspace where we are provisioning or creating our pipeline. Then parallel run step is the all the steps that we pass to our pipeline, right, one by one. Okay, if you have completed our real-time inference, there also we create a pipeline and so on. There we have created multiple steps, right, for data provisioning, data training, testing, and splitting. That was one step, and then training our model and doing an inference for a new data. That was the second step. So we have covered the steps part while creating a pipeline and so on. Okay. So here we are passing the parallel run step. Okay. So as an input to our pipeline parameter. Okay. Now pipeline run an experiment. This is our experiment name. Okay. And this is our workspace. And then we are submitting that pipeline as an experiment. And this will wait till our pipeline execution is complete, and then it will try the out. So let's run this. It is going to take some time. So I'll pause the video and then we'll start again. Completed. Here you can see the steps are being printed, that it has created a pipeline and then pipeline started running. Okay. This is our step run ID for parallel step that we have passed as an input parameter to our pipeline. So that step run is queued. We have only one step, which is the parallel run step, passed on to workspace, passed on to our pipeline. You see the pipeline name, which gets generated randomly. And this is our experiment name, MS Learn and this batch. While the step is running, parallel step is running, and the batch data, you can see when the pipeline will finish running, the resulting prediction will be saved into an output file. Okay, and here with the help of pandas library and this XSUtil library, will try to print the result of that file. Okay, from that text file basically, and we'll try to print the first 20 results from that prediction file. So the file name was here. You see, file name was parallel run stuff text. From that file, we are trying to print 20 first 20 records of the prediction. Okay, so let's run it after this batch inferencing completes. Let's wait for some time and then we'll run this action. Okay, now you see that it is taking help of that Docker image and provisioning the Docker image. Okay, and then it will import all the Python dependencies which was part of our environment file. Okay, so here it's trying to download all the dependencies and then trying to create a Conda environment within our Azure Docker container. Okay, Azure ML environment. So that environment is being set up. Okay, with all these packages. Okay. Here all the packages are being run. Okay, all the dependencies, everything. What next? Once the Docker image provisioning with all the environment is complete, then it is going to run the batches. Now we see that the Docker container is started, and then here all the jobs are being run. Okay, one by one. Taking the workspace, processing inferences. Output is not a single file. Okay. So these are all logs related to our inference being run. Okay. It is still executing. Let's wait for some time. It's been 15 minutes. Okay, so now we see inference is finished. Okay, let's print out the result. So for each of the data or files, we can see the prediction by 0 and 1 as the output. Okay, and since this pipeline is a batch inferencing pipeline, we can publish this as a REST interface. Okay, so that when there is a new batch of data comes, we can use the same pipeline to run the batch inferencing. Okay, so this is the step where we are going to publish pipeline. Okay, and to do that, we are passing on the pipeline name and description and the version. Okay, so let's do that. And it has published our pipeline. This is our REST endpoint. We can print the REST endpoint URL as well here. Okay, you see this is the same exact URL that we have here. Okay, if I hover over it, you can see centralindia.api.azure. It's the same path here. Okay, so that's our endpoint where this pipeline is published as a service, and we can use that endpoint to run a batch inference. So here if you see, now we are ready to call the REST interface. So now that pipeline is published as a web service, and if I'll open the endpoint, here you can see endpoint, batch endpoint basically. Okay, why it is not showing here? Okay, just a minute. Maybe it is not registered as endpoint. So we'll come back to that later. Just to REST endpoint pipeline, we are passing on the endpoint authentication header and the experiment name, and then checking the run ID of the experiment. This is our run ID. Since we have the run ID, we can use the run details or widget to view the experiment as it runs. Okay, so we will use that run ID. We'll pass that run ID here and the experiment name to show the endpoint results, all the different parameters or run history for that pipeline. Okay, here you can see all this. Now wait for the pipeline run to complete and then run the following cell to see the result. As before, the results are in the output of the first pipeline step. So we are going to run it again because our experiment is already completed. We are just going to print the file again. Prediction. Top 20 predictions will print it here. Okay, so that's how our batch inferencing works, and we can expose that batch inference experiment as web service, and we can pass the data to that web service to run the inference for newer batch of data. Okay, let me save this notebook. That's about batch inferencing.